Okay, so we're just doing a factoring review. So the first problem we're going to do is a GCF only. Okay, so what is our GCF? Yes, but what is it? For what? For x. Okay, so 4 is the number. 4 can go into 28, so 4 is a GCF. And they both have x's. So this one has 2 x's and this one has 1. And to be fair, we're only going to take 1 from each of them. Okay, so we're going to take out a 4x. If we take out the 4x, the 4's cancel x squared, so we just have 1x left. Okay, and then 28 divided by 4 is what? 7, and the x's cancel. So here is our answer. X plus 7 cannot be factored any further, so we're done. Okay. Okay, so then we also have trinomials, which is the snowflake. It's when we have 3 terms. So, I was like, is that me? I don't know what alarms I have anymore. 3x squared plus 9x minus 30 is going to be our example. So when we're factoring and even doing the snowflake, what's the first thing we should always check for? A GCF. Does this one have a GCF? 3. 3 can go into all 3 terms, but they don't all have an x, so we're not going to take out an x. We're just going to take out a 3. So when I take out that 3, I'm left with x squared plus 3x minus 10. And now we're going to factor what's left. So I'm going to bring down that 3 because I don't want to forget that it's still a part of my answer. Okay, so A here is 1, B is 3, and C is negative 10. Okay, so I'm going to do my snowflake. So we do AX, AX, A times C, well 1 times negative 10 is just negative 10, and B is 3. So what multiplies to give me negative 10 but adds to give me 3? Remember, we're actually kind of subtracting here because one of them is going to be negative. Yes, you're exactly right. It's going to be negative 2 and positive 5. Negative 2 times 5 is negative 10. Negative 2 plus 5 is positive 3. Now, can 1 over 2 simplify? No. Can 1 over 5 simplify? No, so those are our factors. Right here. From here. So what I circled are my 2 factors. Okay, remember we had to figure out what multiplied to give us negative 10 but added to give us 3. Okay, huh? You can, you don't have to. You could have 3 times x plus 5 times x minus 2. Is that what you mean? Yeah, that's totally fine. Okay, so this one says primed. Well, to prove that it's prime, we have to plug it into the b squared minus 4 times a times c. Okay, well, this is a is 1, b is 3, c is 4. Why is my pen dying? Well, that sucked. Okay, so we're going to plug it in. So we have b squared. Well, that's 3 squared minus 4 times a, which is 1, times c, which is 4. And just type that in your calculator. So 3 squared minus 4 times 1 times 4 is negative 7. Is negative 7 positive? No. And is it a perfect square? No. So if it's not prime, you would have a perfect square positive numbers, like 4. 4 is a perfect square positive number. Okay, what else is a perfect square positive number? No. 1 is, because 1 times 1 is 1, right? 2 times 2 is 4, so 4 is a perfect square. What's 3 times 3? So if it was 9, then it'd be a perfect square and we could factor it. So if it's a perfect square, then you can factor. But if it's not, then you cannot factor it and it's prime. So this one's prime. About? 3 times 3 is 9. Because when you multiply something by itself, it creates a perfect square. So like 3 times 3 multiplied by itself is 9. 9 is a perfect square because if you do the square root of 9, it equals 3. So like 2 times 2 is 4. So 4 is a perfect square because it was the same number that multiplied to make it. So like 1 times 5 is 5, but 5 is not a perfect square because 1 and 5 are not the same. Does that make sense? They have to be the same number. Okay? I'm really sad. Okay. Give up on the pen. So now we're going to look at difference of squares. So our example is this one. So first things first, you should still always check for a GCF. So is there a GCF, 4c squared minus 25? No, there's no GCF. Now, are they both perfect squares? Is 4 a perfect square? Yes, because 2 times 2. Is 25 a perfect square? Yes, because 5 times 5. So remember, we need to find what squared minus what squared. So we know that 2 squared is 4, and c squared is c squared. So 2c squared equals 4c squared. And then 5 squared is 25. So this is your A, and this is your B. So it's A minus B, A plus B. So 2c minus 5, 2c plus 5. So grouping. So grouping is when you have 4 terms, but what's wrong with these 4 terms right away? They're out of order. Okay, so we need to put them in order. So remember, your highest exponent goes first. So this is the 3rd power, and there's nothing bigger than that. So that goes for first. Then this is the 2nd power, the 1st power, and the 0 power. Now it's in order. Does it have a GCF? No, all 4 terms do not have a GCF together. So if you remember in grouping, that's when we cut it in half and we put 2 terms in parentheses and the other 2 terms in a set of parentheses. We make 2 groups. Okay, what's your GCF here? In the first group. 2x squared. So we're going to take out a 2x squared. So 4 divided by 2 is 2. X cubed divided by x squared is just 1x left. We took out 2 of them. Okay, and then 2x squared divided by 2x squared, well, anything divided by itself is 1. Now, what's our GCF here? Negative 1. Remember, you have to take out a GCF, and if that first term's negative, you have to take out a negative. Okay, so when I divide by negative 1, divide by negative 1, I end up getting positive 2x plus 1. Okay, so do my parentheses match? Yes, so that is one of my factors. And then do you remember your leftovers make your other factor? Okay, our last two methods are sums of cubes and difference of cubes. So I don't know if y'all remember, but these are very, very similar. The only difference is where you have a plus and a minus, but everything else is exactly the same. Okay, so sum of cubes, our example is going to be x cubed plus 27. And I don't know if you remember, but you want to find what cubed plus what cubed to find your a and your b. Because this is going to be your a, this is going to be your b. Well, x cubed is x cubed. And then I'll have this on the board here in a second, but 3 cubed is 27. So a is x and b is 3. So now we just plug it in our formula. So a plus b, a squared, well that's just x squared, which is just x squared, minus a times b, which is x times 3. What's x times 3?
3x.
Plus b squared, which is 3 squared, which equals 9. Okay. So last one is difference of squares. This one's going to be a little tricky. That's m to the 9th power, by the way. I kind of drew that kind of low. Okay, so we need something cubed minus something cubed. Well, 64 is 4 cubed. We have that m. Now, we have 9 m's. I don't know if you remember, power to a power means you multiply, so we're going to do the opposite. We're going to divide. What's 9 divided by 3? 3. So power to a power would be 3 times 3, which would give me 9, therefore it's correct. Okay? 125 is 5 cubed. And then again, divide. 6 divided by 3 is 2. Well, 2 times 3 is 6, so it works. So A is 4m cubed, and B is 5n squared. So we're going to follow our formula. A minus B, so 4m cubed minus 5n squared. And then A squared would be 4m cubed squared. Now, what is 4 squared? And then m cubed squared, well, what's 3 times 2? So there's a squared. Plus a times b, well, that's 4m cubed times 5n squared. What's 4 times 5? No, 20. And now m and n are not the same, so they're just going to go next to each other in alphabetical order. Plus b squared, which is 5n squared squared. So what's 5 squared? 25. And then n squared squared, well, 2 times 2 is 4. That one's a lot. I will tell you, working on your practice problem is not as bad. So if you look at the back of this this notes, there is a practice page. Today is your class time to work.